Today in this session, we are going to discuss about the spontaneous and stimulated emission of radiation. So in the spontaneous and stimulated emission of radiation, we are going to cover the introduction, stimulated absorption of radiation, spontaneous emission of radiation, stimulated emission of radiation, and then in distinction between spontaneous and stimulated emission of radiation. So when the incident radiation, the incident photon interacts with the atoms in the energy levels, then their distinct process can be takes place. So when the incident radiation interacts with the atom, then their distinct process, then there is distinct process that three distinct processes are stimulated absorption of radiation, spontaneous emission of radiation, stimulated emission of radiation. Once it absorbs the radiation, it may excited to higher energy state. After going to the higher energy state, then two processes takes place. One is spontaneous, another one is stimulated emission of radiation. Let's see about these three processes in this session. So first of all, stimulated absorption of radiation. So consider two energy levels of energies E1 and E2 such that E1 is greater than E2 for an atom. So E1 is greater than E2. That is, E1 is the lower energy state, E2 is the higher energy state. Let N1 is the number of number of atoms per unit volume in the energy level E1. N2 be the number of atoms per unit volume in the energy level E2. So initially the atom is at the lower energy state, that is at the E1 energy level. When the photon is going to hit the atom which is in the lower energy state, because of the interaction of incident photon, this atom gains energy, so excited to the higher energy state E2. So here this atom which is at the lower energy level absorbs some incident radiation so that it is stimulated and transits to higher energy state. So that's why it is stimulated absorption of radiation. By absorbing some radiation, it gets stimulated, so excited to the higher energy state. So the incident radiation consists of photons of energy equal to the energy difference between E1 and E2. So the incident radiation, so that incident radiation have the energy, so that energy h nu is equals to the energy difference between the two energy levels. That is E is equals to E2 minus E1, energy difference between the two energy levels. So the incident radiation consists of photon of having energy equal to E2 minus E1. So this photon's energy should be equal to the energy difference between the two energy levels E1 and E2. So the number of photons per unit volume of incident radiation is known as incident radiation density, rho of V. The incident photon stimulates the atom in the lower energy level E1 to absorb its energy. After absorbing energy, the atom transits to higher energy state E2. So this process of exciting the atom to higher energy level by absorbing by absorbing the stimulating incident photon is known as stimulated absorption of radiation. So the number of stimulated absorption of radiation depends upon the number of atoms per unit volume N1 in the energy state E1 and the number of photons per unit volume of incident photon or incident radiation, that is incident radiation density rho of V. So here the number of stimulated absorption is proportional to N1. So N1 is number of atoms. Here a number, here N1 is the number of atoms per unit volume in the energy state E1. So a number of stimulated absorption is proportional to number of atoms per unit volume in the energy state E1 and it is also proportional to incident photon radiation density, so that it is proportional to N1 as well as rho of V. So this is equals to N1 B12 rho of V. So where B12 is known as Einstein's coefficient of stimulated absorption of radiation. So if this excited atom transits to lower energy level, so once it stimulated and excited to higher energy level, then the transits to lower energy level even then it emits radiation. So the emitted radiations are of two types. One is spontaneous emission of radiation and then stimulated emission of radiation. In spontaneous emission of radiation, the excited atom in the higher energy level E2 can stay up to 10 power minus 8 seconds. So this is the average time up to which an excited atom can stay at the energy level E2 is known as the lifetime of the excited atom. After the lifetime of the excited atom, it transits to lower energy level E1 by itself emitting a photon of energy. So that energy E is equals to E2 minus E1. E is equals to h nu according to Planck's. So h nu is equals to E2 minus E1. So that implies nu is equals to E2 minus E1 by h. So h is the Planck's constant, nu is the frequency, and E2 is the higher excited, that is excited state, and E1 is the lower energy state. So this process where emission of radiation takes place by the transition of an excited atom by itself to lower energy level is known as spontaneous emission of radiation. So this is the diagram which is related to the spontaneous emission of radiation. So after absorbing instant photon, the atom excites to higher energy level. So now the atom is at the excited state. So after the lifetime of this atom in the higher energy state, that is after 10 power minus 8 seconds, the lifetime of an atom at the excited state is 10 power minus 8 seconds. So after the 10 power minus 8 seconds, the atom itself transits to the lower energy state by emitting photon. This photon energy E is equals to E2 minus E1. So here according to Planck's, h nu is equals to E2 minus E1. So nu is equals to E2 minus E1 by h. So in spontaneous emission of radiation, the number of spontaneous emission of radiation depends upon the number of atoms per unit volume in the E2. So that is N2. So number of spontaneous emissions is proportional to N2. N2 is number of atoms per unit volume in the energy state E2. So number of spontaneous emissions is proportional to N2 and it is equals to the N2A21. So means that here it is not getting stimulated by any other incident radiation. So the atom which is at the excited energy state by itself transits to lower energy level after the lifetime of an atom. So that no incident photon takes place here. So only after the lifetime it fall back to the lower energy state. So that number of spontaneous emissions is proportional to N2. So taking away proportionality, it is equals to N2A21, where A21 is the Einstein's coefficient of spontaneous emission of radiation. In stimulated emission of radiation, the excited atom, after being stimulated by the instant the excited atom, after being stimulated by the instant photon, transits to lower energy level even in a time less than the lifetime that is 10 power minus 8 seconds of an excited atom. So the atom is at the excited energy state already. So before the lifetime of an atom, that is before 10 power minus 8 seconds, this atom is being stimulated by the incident photon h nu, then transits to lower energy level. So while transiting to the lower energy level, it emits photons of radiation. So the excited atom, after being stimulated with some instant photon, then transits to lower energy level even with time less than 10 power minus 8 seconds, less than 10 power minus 8 seconds of an excited atom. So this transition emits a photon of energy, nu is equals to E2 minus E1 by H. So this process of where excited atom after getting stimulated by the instant photon transits to lower energy level by emitting photon is known as stimulated emission of radiation. So this process where the excited atom after getting stimulated by the instant photon transits to lower energy level by emitting photon is known as stimulated emission of radiation. Here you can see the stimulated emission diagram. So here the atom is at the excited energy state. So a photon of energy h nu is going to interact with the excited atom. So before the lifetime of this atom in the excited state, it is stimulated by the instant photon h nu and then transits to lower energy state by emitting photons. So two photons, that is emitted photon, this is emitted photon and then instant photon. So by emitting two photons, one is emitted photon, another one is instant photon. So these photons have the same directions, they are in phase. When coming to the number of stimulated emissions, so the number of stimulated emissions of radiations depends on the number of atoms in the higher energy levels and also number of incident radiation density, that is number of incident radiations. So the number of stimulated emission of radiation depends on the number of atoms per unit volume in the higher energy level E2, and also the number of incident radiations in the higher energy level. So rho V. So number of stimulated emissions is proportional to N2, number of atoms per unit volume in the E2, and it also proportional to the instant radiation density, which is stimulating the excited atom. So it is proportional to N2 rho V, and it is equals to N2 B21 rho V. So that is B21 is here Einstein's coefficient of stimulated emission of radiation. So in this process, in addition to emitted photons, there will be incident photons. All these photons have same energy and same frequency and are in phase. As they reinforce together, it results in high intensity monochromatic and coherent radiation. So that is, we are getting laser radiation here. The distinction between spontaneous and spontaneous and stimulated emission of radiation. So, spontaneous emission takes place when an atom in higher energy state transits to lower energy state by itself by emitting photon. So, spontaneous emission when it takes place. So, when an atom in the higher energy state transits to lower energy state by itself after the lifetime. So, here in the stimulated emission, it takes place when the atom in the higher energy state gets stimulated by the incident photon and transits to lower energy state. Stimulated emission is independent of incident radiation. No need to stimulate the atom which is at the higher energy state. So the atom itself transits to lower energy state. So spontaneous emission is independent of incident radiation density. Here a stimulated emission depends upon the incident radiation density. So after stimulating by the incident photon, the excited atom comes to lower energy state here in stimulated emission. Whereas in spontaneous emission, it has been transits to lower energy state after the lifetime. So spontaneous emission takes place after 10 power minus 8 seconds. Stimulated emission takes place within a time of 10 power minus 8 seconds. That is less than 10 power minus 8 seconds that in stimulated emission takes place. Spontaneous emission is a slow process when compared to stimulated emission because it is happening after the lifetime, but it is less than the lifetime of an atom that stimulated emissions occurs. So that spontaneous emission is a slow process when compared to stimulated emission. Here stimulated emission is a fast process when compared to spontaneous emission. The Einstein coefficient of spontaneous emission is 8 to 1 because it transits from higher energy state to lower energy state at initial first process. So that A to 1 is the Einstein coefficient of spontaneous emission. Here B to 1 is the Einstein's coefficient of stimulated emission of radiation. So these are all the topics which we are discussed. That is we have discussed about the stimulated absorption of radiation, spontaneous emission of radiation, stimulated emission of radiation, and then differences between the spontaneous and stimulated emission of radiation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.